Number 2, a tennis ball is thrown vertically upward with an initial velocity of 8 meters per second. It's asking what will its speed be when it returns to its starting point, and B, how long will it take for it to reach its starting point. So, just like the first problem, we're going to start off with a picture. We have a tennis ball. It's going vertically upward with VI. And same with, last problem. What is it going to do? It's going to go up to its maximum height, and it's going to come back down. So last problem, we were only concerned with from position A to B. What's different about this problem? This problem, we're concerned with this position, and now we're going back down. The problem is asking what will its speed be when it returns to its starting point. This is our starting point. So we're going a step further than the last problem. Okay, what do we know? We know there is a downward force of the acceleration. I'm going to call this V final. Yeah. I'm going to also call this V middle. I don't know if that's going to be relevant in our problem, but I'm just going to label it for the sake of it. What else do we know? Or what else do we not know? The time. How long will it take for the ball to go up and back down? We don't know the time. I'm going to circle these variables that we don't know. We also don't know how high it's going to go. Now, I don't think this is relevant in our story, but I'll just write it down. Okay, we might add more later, but let's go on to step 2. Knowns and unknowns. Knowns. We know V initial, that is 8 meters per second. What else do we know? We know acceleration. It's negative 9.8 meters per second squared. Unknowns. We don't know V final. Oh, sorry, there is something we do know. V middle, we know that's 0. If that's confusing, go back to problem number 1. V final, we do not know. We don't know how long it took, T. So, we also don't know X, but just put that in there. Okay, step 3 now. Equations. V final equals V initial plus AT. I'm not going to explain these this time. I'm just going to write them down. I'm going to number these equations. Number 1, 2, and 3. Okay, it's pretty straightforward. Let's solve. Step 4. A is asking, what is V final? Now, this is a concept that if you know, you don't have to solve for, and you can just write the answer down. I'm not sure how Purcell wants you guys to do this. I'm not sure if she wants you to prove what we kind of know, but I'm just going to tell you what the answer is right now. When acceleration is constant, we have a initial velocity. It goes up and it comes back down. The velocity is going to be the same, just in the opposite direction. So if it's going up at 8 meters per second squared, I already know it's going to be negative 8 meters per second squared. I looked online, and a lot of the solutions just kind of like stated that as fact without solving it or like proving it. And I'm not sure how much Purcell wants you to prove this. It's a known fact, but we'll do it anyway. So I'm gonna think about which equation I can use. Number 1, let's look at it. V final, we do not know. V initial, we do know. Acceleration, we do know. Time, we do not know. So I'm not gonna look at number 1. Okay, we looked at equation number 1. Let's look at number 2. Number 2, I'm automatically going to not even look at because we're looking for v final. V final is not in this equation. I'm going to look at number 3. We have v final, we have v initial. We know 2a, acceleration, and x. This is where I have to apologize to you guys. I initially set this distance that we go up as x. We use a lot of x's in physics, and it can get confusing because they can mean different things. I'm gonna change this to y, the vertical distance that it traveled, okay? But right now, what's pretty special about this problem is that we're looking at position A, and I'm gonna call this B. If you look at the horizontal component, we're in the exact same place. The displacement horizontally is 0. So with that, I think I can use equation number 3 because this x, the displacement, is going to be 0 because we're at the exact same position that we began in. So I'm going to use number 3. V final squared minus v initial squared equals 2ax. We are solving for v final. I'm going to move v initial to the other side. V initial squared. And also, we're going to take the square root. 2ax plus vi squared. I'm going to put in my values to negative 9.8. X is 0. The horizontal displacement is 0 plus vi squared, 8 squared. I'm going to solve for that. This is all going to just become 0. 8 squared, 64. Now, the square root of 64 is 8. But does this make sense? 8 meters per second? No. If it's just 8, that means that the ball is going up. And that's obviously not what's happening in our problem. We have to remember that when you take the square root, there's always that positive and minus. In our case, we want to evaluate which makes sense. Obviously, it's going downward, so it's going to be negative 8 meters per second. Okay, B. How long will it take for it to reach its starting point? We're asked to find the time. Let's look at our equations. I'm going to start with number 1. V final. We do know v final. It's negative 8. V initial. We do know it's 8. We know acceleration and t. That's what we're looking for. I think number 1 sounds pretty fine. So I'm going to use number 1. V final equals v initial plus at. We're solving for t. I'm going to flip it right now. Just how I like to solve my problems. V final. So this came here, this came over here. I'm going to subtract vi from both sides. At, vf minus v initial. Now I'm going to divide both sides by a. So we get tv final minus vi all over a. And now I'm going to put in my values. Final velocity is negative 8. Initial velocity, don't forget the negative. This negative isn't like, don't try and confuse this negative with the initial velocity. This is going to be negative, and then we're going to have our positive velocity. So maybe I should write that down. It's negative positive 8 all over acceleration, which is negative 9.8. We're going to get negative 16 over negative 9.8, which should come out to 1.63 seconds. This should be our answer, and like I said, I do not have the answer keys, so I pray this is correct.